Welcome back, Leo Lions. This is Mrs. Morgan with our lesson on comparing and ordering real numbers. So we're going to get a list of numbers that are maybe decimals, fractions, square roots, and mixed numbers maybe, and then we want to put them either least to greatest or greatest to least. So always read to make sure you know which way we're ordering them. For sake of time, there's two little stars underneath our heading here, and I wrote in what those two little stars are for. I would highly suggest that you zoom in. When I zoomed in real far so that I could write big, and then when I zoomed out it stayed small. So the first star, numbers must be in the same form. And then I put a little arrow and said decimals. I like to change everything to decimals. Working with fractions usually creates more work because then we have to also find common denominators with the fractions before we can compare them. So numbers must be in the same form, preferably decimals. And then as a reminder, I put here, make sure you show all the numbers as decimals before we order them. That helps us put them on number line. That helps us put them in least to greatest. If you do not show me that step, then I don't know your thinking. I don't know how you put them least to greatest. So I also put that down there. The second star then in purple, write numbers in order using their original form. So we're going to change them all to decimals. But then when we order them, we want to put them in the original form that they were given. So we put them back to that form, okay? So let's look at some examples. The first example is about comparing real numbers. So we're going to use one of these three symbols. This is a greater than symbol, this is a less than symbol, and this is an equal to symbol. The way I help students remember is if you take your left hand and make an L, and then you turn it a little bit this way, then that's a less than sign. So left hand, less than, L, they all start with L's, okay? And then the other one's greater than. Remember, it always opens towards the bigger number. The alligator wants to eat the most, okay? So right now, in this first example, we have the square root of 34, and then we have 5 and 5/8. So we're going to want to write them as decimals. The square root of 34, now we're going to have to estimate because that is not a perfect square root. So I know in class we've made this list often. If we make the full list up until we get to 34, so 1 times 1 is 1. That is a perfect square root. 2 times 2 is 4. So that's a perfect square root. 3 times 3, 4 times 4, 5 times 5, and once we have this list, then it makes it easier to figure out where would the square root of 34 go. So 6 times 6, 7 times 7. Now I'm going to pause there for now because the square root of 34 is going to be very, very close to that square root of 36. So the square root of 36 is 6. 6 times 6. And the square root of 34 is right before it. So I'm going to guess that this is about, and I'm going to use this little squiggly equal sign. That means approximately, we could say 5.8, maybe 5.9. I'm going to guess about 5.8. Okay, so there it is as a decimal. Now, 5 and 5/8. Now we know this is 5 point something. And then the fraction part, we're going to do 5 divided by 8. So 8 goes into 50 6 times. We get 48. Subtract. Bring down your 0. 8 into 20 is twice. That's 16. Subtract them. We get 4. Bring down the 0. 8 into 40 is 5 times, and there it comes out perfectly. So 5.625. Now that we have both of them as decimals, what we can do if you don't know how to compare decimals, we can stack them. So if we put 5.8 on top and then 5.625, now remember, next to this 8, there are really invisible zeros here, forever and ever, okay? Now to compare, we compare place values. So we read it from left to right, we look at the first place value. If they're the same, then we move on to the next one. So we move on to the 10th spot. Those are different. So the one that is bigger, the 8, is bigger overall. So the square root of 34 is greater than 5.625 or 5 5/8. Okay? Now, the next one I am going to skip. I do not like this problem, so you can just simply cross it out. Those numbers are really, really, really close. So that's why I don't like that example. Okay? Now, next examples, we're going to take a big long list. So we have 1, 2, 3, 4, 5, 6, 7 numbers. We're going to first put them on the number line, and then we're going to order them from least to greatest. So our first step is let's put these all in decimal format. There are a couple that are already in decimal format. So let's look at 1 3/7. So we know this is 1 point something. And then again, we can come off to the side and do 3 divided by 7. 7 goes into 30 4 times. That's 28. Subtract and bring down your 0. 7 goes into 20 twice. We get 14. Bring down our 0 again. 7 into 60. 8 times. 56. 7 into 40. 5 times. I thought it was going to end, but I do not see an end in sight. So I'm going to pause there because a lot of times if you have the first several place values, you're pretty close. You can compare it or order it to other numbers. So I'm going to actually do this in a different color so you can see where I'm at. 1 3/7 is 1.428, and I doubt we even have to go further than that. All right, 2.5 is already a decimal, so we can skip that one. We're good to go there. The negative square root of 9, so we know this is negative, and then the square root of 9, we wrote up here on the side, so this was 1, 2, 3. 3 times 3, so negative square root of 9 is negative 3. 3.5 is already a decimal. We're good to go there. Negative 2.2, we're good there. Negative 4 5/9, so we know this is negative 4 point something. And then we'd have to do our 5 divided by 9. I'm going to come off to the side here and do 5 divided by 9. 9 goes into 50. 5 times, that's 45. Subtract them. Bring down our 0, and if you notice, it's the same number. So this is going to be a repeating decimal. So negative 4.555, so on, so on. And then the last one is negative 30 over 6. So think about 30 divided by 6. Well, 6 goes into 30 a perfect 5 times. And then don't forget about the negative out front. So that's negative 5. Okay? So let's put these on the number line. 1 3/7, so 1.4, so on, 1.42. So here, let's write down all of our numbers. So 1, 2, 3, 4. About right in the middle of 1 and 2 would be 1.5. So I'm going to go a little less than 0.5. And there is 1 3/7. If you noticed, I used the original form that it was given in, the mixed number. 2.5, so directly in between 2 and 3 is 2.5. You may be able to hear my dogs crying. Negative square root of 9, so I'm going to again label these numbers negative 1, negative 2, negative 3, and negative 4. So negative 3 is right on that line there. So negative square root of 9. 3.5, so that falls directly right in the middle of 3 and 4. And then we have negative 2.2. So it's going to be between negative 2 and negative 3. You really have to be careful with the negatives because you go backwards. So negative 2.2 is about right here. We don't want it on the other side because then that would be in between negative 1 and negative 2. So that'd be negative 1 point something. So that's why we go the other way to the left. So that's between negative 2 and negative 3. negative 4.555, so on. So again, we need it between negative 4 and negative 5. And I'm going to write that in its original form. And then last one, negative 30 over 6, simplified to a perfect negative 5. So that one is negative 30 over 6. All right, once we have them on the number line, well, you can see them in least to greatest. So let's order them. Our first one, and I'm going to write my final answer in a different color here. Our first number on that line is negative 30 over 6. Then we have negative 4 and 5/9. Then we have the negative square root of 9. Then we have negative 2.2. And then all the other ones are right below here. So 1 and 3/7, 2.5, and 3.5. And I always double check in the end. I have 1, 2, 3, 4, 5, 6, 7 numbers. And if you remember in the beginning, I counted the numbers, and there were 7 that we started with. 1, 2, 3, 4, 5, 6, 7. So we know we got all of them. We got them on the number line, and we ordered them from least to greatest. Okay? Let's do 2 more examples. 2/3. I do know some of these off the top of my head. If you don't, then I would like you to do 2 divided by 3, but this is a repeating decimal, 0.6 repeating. Negative 1.8 is a decimal, so we don't have to change it. Square root of 25 is 5. Negative 3 and 4/5. 4/5 is 0.8, so negative 3.8. Negative 3.9 is already a decimal. Negative square root of 19. So let's come up here to that list we made in the beginning. The square root of 19 is going to go somewhere in between here. So the square root of 16 was 4. Square root of 25 was 5. So we know the square root of 19 is going to be 4 point something. It's pretty close to the square root of 16. So let's say we're just estimating it's about 4.2. All right. There is a negative in front of there, so it'd be negative 4.2. And then 0.5 is already a decimal. So let's order all these. 2/3, 0.6 repeating. Again, I am going to number my number line. So 0.6 is about in the middle of 0 and 1 and a little to the right of the middle. So this is 2/3. All right, next one, negative 1.8. Again, I'm going to number all of my negatives. So negative 1.8 needs to be in between negative 1 and negative 2, and it needs to be closer to negative 2. And I'm going to double check. It was given in decimal form, so we can write negative 1.8. Square root of 25 comes out to the whole number 5, so that is right on that line of 5. That is square root of 25. We have negative 3.8. So that is, again, in between negative 3, negative 4, but closer to negative 4. It's past the 3.5. So this is negative 3 and 4/5. Negative 3.9. Ooh, that's really close. So these guys are right next to each other. And I'm going to have to make a line over here. That is negative 3.9. Negative square root of 19, so that was negative 4.2, so that is about right here. And I'm running out of room to label all of these. So negative square root of 19. And then 0.5, so a little less than our 2/3. That's going to be right in the middle. Okay, now once we have them all on the number line, well, we can just write them least to greatest. Some of those numbers were pretty close. But we can see now that they're not exactly the same. They are different. So the first one there is the negative square root of 19. And then negative 3.9. And then negative 3 and 4/5. And then negative 1.8. 0.5. 2/3, and the square root of 25. So we have 1, 2, 3, 4, 5, 6, 7 numbers. Exactly what we started with. Okay, one more, 18 divided by 4. So 18 divided by 4. 4 goes into 18 4 times. We get 16. Subtract them. I'm going to add my decimal and my 0. So 4 into 20 is 5 times. So this is 4.5. Negative 2 1/6. Negative 2 point, and I'm pretty sure it's 1/6 repeating. Let's try this. 1 divided by 6. 6 goes into 10 once. Subtract them. 6 goes into 40 6 times. And I did know that. 4, and there we go. We see it repeats. So negative 2.1, and the 6 repeats. Square root of 10 is super, super close to that square root of 9 up here. So there we go. The square root of 9 is 3. And then we know the square root of 10 has to be right after that. So I'm going to estimate it to be about 3.1. All right. Negative square root of 10, so it's the same thing, just the negative of it. 2 squared, 2 times 2. Negative 2.8 is a decimal. And then negative 15 thirds, negative 15 divided by 3. 3 goes into 15 5 times, so it comes out to an integer, a whole number. All right, again, last step here then. Let's number our number line, put all of them on here, and then write them least to greatest. So the first number we have is 4.5, directly in between 4 and 5. This is 18/4. Then we have negative 2.1666601. So negative 2.1 needs to go in between negative 2 and negative 3, but it's going to be closer to negative 2. So that is negative 2 1/6. Square root of 10 we estimated to be about 3.1. And then the negative square root of 10, same thing. Make sure you go on to the left side of negative 3, because it's got to go in between negative 3 and negative 4. So negative 3.1, or negative square root of 10. 2 squared is 4. Negative 2.8. So negative 2.8 needs to go in between negative 2 and negative 3, closer to negative 3. And then negative 5 is our negative 15/3. And last up, let's write them in order from least to greatest. So the first one is negative 15 thirds. And remember, we write them in the original formats, not what we changed them to. Then the negative square root of 10. And then negative 2.8. Negative 2 1/6. Square root of 10. 2 squared. And 18/4. 1, 2, 3, 4, 5, 6, 7 numbers. We are good to go. So that concludes our lesson. If I give you a list of numbers that are decimals, fractions, square roots, can you put them in their decimal format, and then can you order them